All right, everybody. So it is 4 o'clock, and I'm going to go ahead and get started on this October 9th meeting. So over the past 5 weeks, I believe we're on week 6. Over the past 5 weeks, we've been doing a lot of work with analyzing motion, seeing different types of motion. We've been seeing constant velocity motion, motion that is accelerating, and most recently, free fall motion. And during all of these assignments, I have been providing you with these very accurate videos. So the data we've been getting has been quite good. In the next couple of weeks, we are doing a sort of midterm exercise. And in this midterm exercise, we're going to be analyzing things that are more real world, more realistic to your life experience. And that's going to be taking place through uploading various videos of moving objects. And because it is not going to be in this sort of laboratory settings, it is not going to be as precise. So first, as you go into this exercise for this next couple weeks, I want you to understand that like your data, it's not going to be perfect, and that is okay. We're not looking for perfection, but we are looking to implement those tools we've been learning. Now, since none of the information that we're going to be utilizing from a physics perspective is going to be new for these next couple weeks, it is still an analysis of like motion and position, velocity, and acceleration. Since none of it's new, we're going to do a little bit of a different type of lecture today. I'm going to be walking you through some of the key tools and techniques that you're going to be needing to interact with Pivot throughout this lab. So I'm going to talk for a little bit about how to utilize this week's Pivot account, and um, let's go ahead and jump into that. So we go over to Pivot, and I'm going to share my second screen. And on this screen, you should be seeing my Pivot browser or my web browser with Pivot on it. And this week's activity will take place in 4 parts. In the first part, we will be analyzing the motion of Jesse Diggins, a Olympic athlete. And all of us will be assigned different trials. Between the different trials, there are going to be options of backpacks, no backpacks, frame rates will be changing. And we're going to go ahead and we're going to look at, I'll put on trial one backpack and press play. And during this motion, we see Jesse Diggins running uphill, and we can do our usual sort of analysis where we pull out a measuring tape, and we won't actually need that for this activity, the compass, but we can pull out our measuring tape, and it's already calibrated, so we can go ahead and we can measure where is Jesse Diggins' position as a function of time. Now, here's the difference this week. When we look at our tables are completely empty to begin with. We have to fill them out. When we fill them out, we want to start with the name. What is this thing that we're measuring? And in this case, we are probably measuring time, as we usually do, as well as position. When we come down here, we ask, what are the units? Well, is in units of seconds and position is in units of meters. We want to make sure to add in all of these key elements that we like. If there's another column we want to add, we can go over to settings and see the data table and graph help, and it can tell you all about how to add different columns. That tells you label, how to add different columns, how to remove columns, and how to add rows. So very useful tool here to go to. In our case, we probably want to insert a column. I'm going to insert a column to the right. Let's say we're analyzing motion where our velocity is changing. If our velocity is changing, we might want to put in a column for velocity. Of course, units of meters per second, or perhaps we're using centimeters in the later measurement. Centimeters per second might also be a good indication of our units. Now, in this variable set, this isn't really that critical, but typically we would represent like T for time, X for position, and V for velocity, right? We go through, and with Jesse, we can map out her location at various times. And let's say we look at, I don't know, every 2/10 of a second. So 0.246, 0.81. And let's say we wanted to go further, we could add more rows. So we can insert a row below and we can look at maybe 1.2. So we can add as many rows and as many columns as we want. Generally in this lab this week, for your constant velocity motion, you're probably just looking at time and position as we've done before. But when we have acceleration, depending on the method you want to use to measure acceleration, we saw a couple different methods. Depending on the method to calculate our acceleration, we might want 3 columns, one for time, position, and velocity. So it's important to remember these are the different characteristics we might want to keep track of. When we go down, we can insert our measurements into this table that is provided, and we have the 3 quantities that we may have measured. So time, position, and velocity. And you can see it auto fills out the title with position and in parentheses the unit. So we might do position versus time, for example, and have our graph created for us. Now, I don't have any data put in here, but it would autofill here from the above table. And titling the graph, you might title it Jesse Diggins. What am I looking at here? Trial 1 with backpack. Whatever you wanted to name it. So just like before, data autofills, and if we go back and change our data in the data table, we'll change the data in the graph. Sort of scrolling down a little bit, we have a new addition to the sort of techniques that I'm going to ask you to be doing. Throughout this lab, yes, the first video is of Jesse Diggins. It's one that's provided to you, but I'm also asking you now to provide your own motion. I want you to provide your own examples of motion taking place. So I'm going to show you an example here in a second. But when you do this, you're going to take a video, probably with your cell phone. And in your cell phone, you want to make sure that your video has a stationary camera, that your video includes something to reference for size. I gave a couple of examples here. Piece of paper is 21.6 centimeters by 27.9. This is your typical letter size paper. Can of soda is another option. A baking sheet. Most of us have baking sheets around the house, I think. So, a couple of options for what to use. Though you are not limited to this, you can use other objects um, for your reference. And in the video where it gives an example, they actually have a ruler that they use for a reference. Rulers are great because they are well known in their size. But it could be anything, and I'll show you an example in a second. And then you're going to be looking at different objects. In this first one, you're looking for an object that is moving at a constant velocity. So I took a video earlier today and I'm going to upload it right now. So when you go over to the screen, you see choose file. You can choose file. It opens up, and in my downloads here, I have 2 videos. I'm going to choose the one on the right first. And when I chose the one on the right, it comes up with an error. It says this type of video is not supported. Depending on the camera that you're using, you might be on an unsupported file type, or your video might be too high quality. If it's over a certain file size, it won't upload. So you might need to convert your file. And how do you do that? Well, there's a nice little link here that'll take you to a document that tells you how to convert it, but it sends you to this Cloud Convert. This is a free website where you can convert from one format to another. You might select file, select the file you want to convert, and then you select MP4. When you're converting to another file for Pivot, you're most likely going to want to convert to MP4. In some instances, it does actually take OV files, but I think that has a strict file size associated with it. So converting it to MP4 is probably the safest bet. You press convert, it'll convert and allow you to download a now MP4 version of this file. With that MP4 version, you can upload it. So go choose file. That's what this other file I had here was. It's just an MP4 converted version of this video file. Go to open, select the frame rate that you have for your file. If you don't know how to find the frame rate, I can show you in Windows. I'm not too sure in Mac how it works, if I'm being honest. But if you go to Windows and you take a look at your file, you can right click and go down to properties. And in the properties under details, it will tell you the frame rate of your video. So my video is 30 frames per second. So we're going to go ahead and utilize 30 frames per second as being our recorded frame rate. The playback frame rate should be about 30 here, rounded to 29.9. That's okay. That's perfectly fine. We upload and you see the video. Now, I'm not going to play it immediately. I'm going to actually first mute the site because I don't want it to play the sound. It will play sound when you play it, but we don't need that right now. So here is a backyard fence, and on this backyard fence, I know the distance between posts. For my backyard fence, the distance between posts is 180 centimeters. So I'm going to line up this calibration tool, and I'm going to come down here. I'm going to write, well, what is the distance? 180 centimeters. And it's about 180. I think it's actually technically 182 centimeters, but we're going to round to 180. With this calibration tool, if you have a white background, you might choose a different color. I think here you can see most clearly in green, so I'll select green just for the sake of this video. But you can select the different colors to make sure you get a nice and precise size for your calibration tool. All right, and then the question is, what is the we're going to analyze? I'm going to play this video, and we're going to see first me run past the screen and then followed by my dog. So my dog runs past the screen, and that is the motion that I want to analyze. It's a roughly constant velocity. The pace was pretty constant, not speeding up, not slowing down. So taking a look at this video, I can measure how quick my dog is running. So let's see. I'm going to pick a frame where she starts out right on the far right side. And when I do this, I'm going to take the same methodology that I've done in the previous labs where I might line up a measurable part of my dog on the scale. Now here we see that I've lined my dog up with the 300 centimeter mark. So I come down here and I say, what am I measuring? I'm measuring the time and the position of my dog. Time in units of seconds, position in units of, in this case, it's actually centimeters. Depending on how you calibrate it, if you calibrate it off of meters, it's going to be in meters. If you calibrate it off centimeters, so this ruler is based on the calibration that we've set. So I fill out my data. I can write 3.1 seconds. My dog is at 300 centimeters, or I can reset it so that it's 0 at 300 centimeters. I'm going to move forward a few frames, maybe to about, we'll say right there. She's nearly at the 250 mark. It looks like she's at 251-ish. So we'll say 251 centimeters. No, that would be 250. Let's see. It's 252. Just get it as close as you can. You don't have to seek perfection here. Go forwards, few more frames. We see that my dog reaches at 0.4 seconds. It's about at 200 centimeters. Keep advancing forward. And at about 0.6 centimeters, she is at 150, and we just keep going forward, right? This is the same thing that we've been doing in previous labs. Let's see. 0.8 seconds. She is at, what would that be? About 90, I don't know, about 95. And then if I wanted to, I can insert a row below and look at the 1 second mark, finish this off. The 1 second mark, she is about, let's see, so it's 10, 20, 30, about 35, somewhere in that range. So we have her motion and we put it into our graph. We put position on the vertical, time on the horizontal, and we title the graph Princess, the name of my dog, Princess Running. And we see that the data comes out pretty linear. She ran at a pretty constant speed. We ask the question, well, how fast is she going? And this is the same sort of relationship that we've done previously. We just fit a linear graph to it. You see that Princess is running at negative 264 centimeters per second. That is to say she is moving negative left 264 centimeters a second. So we have that. We then go on to describe an example of Princess running. So we describe an example, or sorry, we describe uh how it is that I know she's running at a constant velocity. This is stuff again similar to what we've done in previous weeks. And if you get stuck, really strongly encourage you look back on the discussion posts that we've discussed that we've done. We also have a question of making a motion map. We haven't done that, but it is just drawing out a motion map on a whiteboard or piece of paper, whatever you need to do, and then you can upload it with a picture. So you go to image, choose file, and then you can upload an image, and then determine the average velocity. Well, I did that earlier with my graph. And I will be looking at these videos, looking at the graphs, checking your work, seeing does it look good. The one thing I want to remind you is to make sure to label your graphs. It's important to label things and to know, what it is exactly that we're graphing. For your straight line motion, it should form a straight. First, this is actually activity 2. For the constant velocity activity, it should form roughly a straight line. Now, that being said, our data is not going to be perfect, and that is expected. If we take a look at Princess's running, you can see that the dots are not exactly on a straight line. In fact, it's a little bit curved. It's a little bit curved. We can actually say that she was accelerating, and we can go through the process of finding acceleration similar to what we did last time, either through the curve fit of a quadratic. When we do this, we get a the acceleration isn't 32.1, right? Half of the acceleration is 32.1. So she's actually accelerating at 64 meters per second squared, centimeters per second squared, my apologies. So we see that we can find the acceleration that way, or we can go through the process of finding the velocities at different points. So that's this week's lab. Again, it's not so much different in the physics. The physics is the same. It's just a difference in now we are analyzing stuff that is in our world, right? We're analyzing things that are around us. And we're analyzing less perfect motion. All right, so this is going to be the next 2 weeks. I'm going to sign in next week and talk a little bit about the third and fourth part of this activity in case you guys haven't finished it at that point. Take your time on this. Find good examples of motion. Try and be creative. And if you need anything, as always, I am here to help. Okay, I'm going to end the recording now.